Welcome to our tutorial on how to create a functioning keyboard with your Arduino. We will be including 4 different frequencies that will in turn create the different notes. You will need the following parts: 4 long jumper wires, 5 short jumper wires, 3 should be the same colors to distinguish where they go, 1 piezo buzzer, 4 push buttons, 1 220 ohm resistor, 2 10 kilo ohm resistor, 1 kilo ohm resistor, 1 breadboard, and 1 Arduino.
Start by positioning the 4 buttons with 1 slot in between them. Then attach small wires from the positive sides of the buttons one by one. Next, you will connect the negative end of the first button to the negative terminal on the breadboard. You will now attach the resistors in the order they were told. The purple wire that has just been placed will be on one side of the buzzer, the other end connects the buzzer to the positive terminal on the breadboard. The brown wire that has been placed connects the negative terminal of the first button on the A0 port on the Arduino board. The yellow wire will attach from the other side of the buzzer to port 8 on the Arduino. The black wire connects the negative terminal to the 5-volt port, and the red connects the positive terminal to the ground port. Finally, the blue USB cable can be plugged into a port on your computer with the code that we will take you through now.
Arduino code consists of 3 parts: the integers, setup functions, and the loop functions. The integers are the first thing you declare in the Arduino code. For this project, we will declare all the notes we will be using. It looks like this. Next, we will use the setup function to initialize the different parts we will use in our circuit. The serial.begin function will set the data rate in bits per second to transmit the serial data. In this case, we will transmit 9,600 bits per second. The last bit of code we must write in the loop method, and what we will write will allow the circuit to run continuously, hence the name loop. We will first declare the integer of sounder, which is code speak for buzzer. We are telling the Arduino that it is connected to the A0 pin on its board. This will communicate to the Arduino to use the buzzer. The if and else if statements code the buttons to play the specific notes by stating the frequency. The last else statement tells the Arduino that when the button is not pressed, there is no tone, or the note stops playing. This is the last line of code and must finish with closing all brackets. After this, you will press the upload button at the top of the application, and this will send the code to the boards, creating the sound that you hear.
As a bonus, we have added 4 LEDs to spice things up. The extra materials you will need for this are 4 220 ohm resistors, 4 LEDs of different colors. In this example, we have used 2 red, 1 yellow, and 1 green, and 6 long wires.
On the opposing side of the breadboard, you will place the first LED with the negative end in the hole in the breadboard that is parallel to the one in between the first button, as to not disturb the buzzer circuit. Place the positive end on the breadboard with one hole away from the negative end in the same horizontal line. Do the same with the rest of the LEDs like so. You will now place the resistors in the same vertical line as the negative end of the LED, with the other end attached to the negative terminal of the breadboard. To return the electrons to where they came from, creating a closed circuit, wires attaching to the positive end of the LED with the other side in pin 10, 11, 12, and 13, respectively, will do this.
For the code, these pins must be declared as integer LED pin equals 13. For example, if it were connected to pin 13 on the Arduino. For the other pins, since there are multiple ones being programmed at different times, you must change LED pin to LED pin 2 or 3 and so on. Whenever LED pin is declared in setup or loop, you must remember this. In setup, you will place the code pin mode LED pin output, which declares the pins as a source that accepts the electricity and does something with it. This should be done for LED pin 2, 3, and 4 as well. In loop, since the pins have been declared as an output source, we will code them as digital write, which is the code that tells the board to send the current through. Since we declared the LEDs in pin mode, this disables the internal pull-up resistor, which acts like a large current limiting resistor, and the electric energy would not flow through the LEDs, causing them to be dim. To create the on-off effect, we must say that they are high or on, and then low or off. We will set the LEDs to stay on for 100 milliseconds and stay off for the same amount of time by using the delay function. The following code is what you will use for each LED.
After you have set up the board and written the code, it is time to try it out all together. This is the result. The LEDs are in parallel to the buzzer, that way they do not interrupt the sound that it creates. Now you have what we like to call a casino keyboard.